All right, so now we're going to do the application problem. We have a business problem. This is number 28. It says a company that produces DVDs uses a formula C equals 88n to the 1/3 power plus 330 to calculate the cost in dollars of producing n DVDs per day. What is the company's cost? We want to know cost to produce 150 DVDs per day. Round your answer to the nearest dollar. Okay? So they tell us that cost equals 88 n to the 1/3 power plus 330. And always it's good to write your givens, what everything means. So remember, C is cost, and that's in dollar amounts. And then N is your DVDs, right? Amount of DVDs per day. Awesome. So they want to know, this is what's given, and we want to know, what do we want to know? What is the cost? So that's what we're trying to find when they produce 150, so my N equals 150 DVDs per day. So to find the cost, I'm just going to go ahead and plug in what I know, right? 88. Now I can rewrite N to the 1/3 power as the cube root of N, right? Plus 330, and my N is 150, so I have 88 times the cube root of 150 plus 330. Now I can go ahead and plug that into my handy dandy calculator. So I turn it on, so I'm going to write 88 times, so math cube root, so math button right here. And then I'm going to hit number 4. That's the cube root button. And I'm going to type in 150. Make sure you close your parentheses because I want to make sure that is the only thing underneath the radical, underneath the cube root. And then I'm going to add 330. Hit enter. And so I end up getting 700. So my cost is $797.57. And they want us to round to the nearest whole dollar. So this would be $798 would be the cost. So number 29 says write the equation in number 28 in terms of N. So that should actually say in terms of C. That just means, guys, when it says in terms of, that means you want to solve for N. So that way you have C in the equation, which means you want to get N by itself. So again, right now it's actually in terms of N because you have your cost is in terms of N. But here they want us to do it backwards. They want us to actually find N in terms of C, so solve for N. So for number 29, I have C equals 88 N to the 1/3 plus 330. So I want to solve for N. That's really what this problem's asking us. They just kind of worded it differently. So I'm going to go ahead and rewrite this as the cube root of N So then I'm going to go ahead and subtract 330. So then I have cube root of n, like that. And then I'm going to divide by 88. So I have your cost minus 330 divided by 88 equals the cube root of n. And then if I want to get n by itself, I'm going to cube both sides. So I have n equals c minus 330 over 88 cubed. And I can go ahead and do an I heart math right here to simplify further. I heart math, math hearts me, doing my math correctly. Da da da, da da da, da 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 da. This would be c over 88 minus, and then 330 divided by 88. If I reduce that, that's 15/4. So you can write it like this. Another way you can write it is 1 over 88c minus 15/4 cubed. All these are mathematically correct, just different forms to write it. And that's it, guys. That's the answer number 29. So let's go ahead and go to number 31. It says the function y equals a cube root of 3x over 4 pi models the radius of a sphere in centimeters when the volume is x cubic centimeters. What would be a reasonable range of the volume for a sphere with a radius between 4 centimeters and 12 centimeters? Okay, so let's go ahead. There's a lot going on here. So we have this function. This is number 31. Y equals the cube root of 3x over 4 pi. Models the radius of a sphere in centimeters. So y represents, guys, the radius in centimeters. And then the volume is x. So x represents the volume in cubic centimeters, so centimeters cubed. They want to know what would be a reasonable range of the volume. So we're looking for volume. That's what we're looking for. We need to find the volume when the radius, they give us two radiuses, is between, so that's your y, right? Your radius is between 4 centimeters and then also 12 centimeters. So we're going to do, this is like a two-part problem. First we need to find volume, and volume is represented in your x variable, so I want to get the x by itself. So let's first solve for volume. Solve for x, which is volume. So how do you get volume by itself? First thing you're going to do is you're going to cube both sides to get rid of the cube root. So y cubed equals 3x over 4 pi. Then what I like to do is I'm going to rewrite y cubed as y cubed over 1 equals 3x over 4 pi. I'm going to make a fraction equal a fraction, because then I can cross multiply. I have 4 pi y cubed equals 3x. And it's always good, 4 and pi are constants. They're numbers, so it's always good to have your number first and then your variable. And then I want to solve for x, so I'm going to divide by 3. So I get 4 pi y cubed over 3 equals your x. This is your volume equation. And so now they gave me two radiuses, right? And radius is y. So I'm going to go ahead and check what they would be, because I'm looking for the range of what the volume would be. So I'm going to go ahead and plug in a 4 and then a 12 for my y value. So my first volume, that's our x, equals 4 pi, my radius is 4 cubed over 3. And then my second volume is going to be 4 pi 12 cubed over 3. Let's see, so 4 cubed times 4 gives me 256 pi over 3, and 256 divided by 3 is around, if I plug in my calculator, 85.33 repeating. So then here, let me go ahead and solve this guy. This would be 12 cubed times 4. Actually, wait, hold on. I forgot to plug in pi. 256. So when I'm plugging this in, guys, it's going to be 256 times pi divided by 3. There we go. So 268.08. And that's centimeters cubed. And then here, it's going to be 12 cubed, so 4 pi 12 cubed, just like that. Enter, divided by 3. So I get 7238.22, or 23 centimeters cubed. And so this, guys, is your range between these two volumes. So my volume would be between 200, that's the smallest it would be, and 7,238.23 centimeters cubed. There we go.